How does hydrostatic equilibrium make dwarf planets round? Imagine a tiny planet trying to hold itself together in space. How does it become perfectly round instead of jagged and irregular? The answer lies in a concept called hydrostatic equilibrium. When a celestial body reaches a certain size and mass, its own gravity starts to pull everything inward. This inward pull creates pressure inside the body. When the pressure balances the pull of gravity, the body is said to be in hydrostatic equilibrium. For dwarf planets, this means their gravity is strong enough to shape them into a round form. When they form, their mass pulls all the material toward the center. As the material moves inward, it becomes softer and more plastic, meaning it can flow or deform over time. This process is called gravitational relaxation. It allows high spots or irregularities on the surface to sink down and fill in, smoothing out the shape. The size of the dwarf planet plays a big role. If it is large enough, gravity can overcome the strength of the materials making up the body. For example, bodies smaller than a few hundred kilometers across usually stay irregular because their gravity isn't strong enough to pull everything into a sphere. But once they grow bigger, gravity takes over and molds them into a rounded shape. Rotation also influences the shape. If a dwarf planet spins slowly, it will be nearly spherical. But if it spins quickly, it can become an ellipsoid, which means it is slightly flattened at the poles and bulging at the equator. Take the dwarf planet Haumea, for instance. It spins very fast and has an elongated shape because of this. Internal layering is another factor. Many dwarf planets have dense cores and lighter outer layers, like ice or rock. This layering helps them stay in hydrostatic equilibrium because the denser parts sink inward while lighter materials stay on the outside. Understanding hydrostatic equilibrium helps scientists classify dwarf planets. It explains why some bodies are round and others are not. It also helps us learn about their internal structure and how they formed. So, in simple terms, when a dwarf planet is big enough, gravity pulls everything into a smooth, rounded shape, and hydrostatic equilibrium is what makes that happen.